Hi viewers, I welcome you all to this video. So in this video I would like to discuss about another leet code problem. It is root to leaf path in the binary tree. So here it's about we have to identify and display all the different paths from the root node to every leaf node in our given binary tree. So from this example you can understand. So we have leaf node 4, 5, 3. Okay. So we have to display the path from 1 to 4, 1 to 5 and 1 to 3. So that's why we have the output like 1 to 4, 1 to 5 and 1 3. So this is what actually the results of the root to leaf path. So how it works? So now I come to the pseudocode which is required for implementing this to understand this. So the depth first search which is used with backtracking, and the algorithm is start from the root node, and we have to add the current node in a vector or list. In the sense we have to create a list for each path. Okay. Then if the current node is a leaf node, so once we have reached the leaf node, so that is for the end of our traversal for the particular leaf node, then we have to display the path from the root to the leaf. So the list which is what updated in each level of the traversal, so we have to display the nodes from the list. If it is not a leaf node, in the sense it may be an internal node, it may have children also. So what we have to do is recursively we have to do the above two operations, and afterwards we have to display the results whenever the leaf node are encountered. So the time complexity of this approach is what we go of n space, which is what based on the height of our tree. Okay. So now I come to discuss with an example. So here you can see the example like a small tree which is given 1 is the root node. Under 1 we have left subtree side we have node 2, and in right side we have node 3, and under the node 2 we have node 5 and node 4. Okay, node 4 is in left side and node 5 is in right side. Now we should initialize the root node first. Afterwards we have to traverse. So we have to start from where. So whenever we do traversal, automatically we go with what? Root left left. Okay, so first we reach the left side leaf node, that is what node 4. Once the leaf deduction is happened, that means once we reach the node 4, so what happens is we have to display the list. Okay, afterwards we go back to the previous stage of the node 4, that is what node 2. Then we have to explore the path of the right side of node 2, that is what 5. So we have to repeat this in right subtree. Okay, we have to repeat this whenever it is there, but according to the node 2 we have reached the leaf node 4 and we have reached the 5. So the print operation will be executed to display the path from 1 to 4 and 1 to 5 which is going through node 2. Okay, and finally which comes back to what the right subtree of the node 1 where we have node 3. So afterwards what happens is a leaf node is encountered when we processing node 3, so the list will be displayed. Okay, now I take you all to the code what we have for implementing this. So here you can see a path which is what declared. I mean, we may have under number of nodes in a path, so this is what the maximum size we take into the list, and we have the node structure. Afterwards a function which is used to return the node for the given input data, and apart from that, so to display the path, so display the different path from root to different leaf nodes, we have a display function. It is what is similar to what display the elements of an array. Okay, so here the path length has to be given, and the path, that is what the source list which consists of the different nodes, to be displayed in a path. Okay, afterwards, yeah, now we come to the function find paths. This is the function we are going to use for identifying the root to the leaf nodes. Okay, I mean the paths. So in the main function we have the tree. Okay, here you can see the tree. So In the left side we have node 2 of node 1, in the right side of node 1 we have node 3. As like that, under 2 we have node 4 and 5, and in the right side of node 3 we have node 6. So the different paths, so here it is about what the leaf node. So 4, 5, 6, these are all the leaf nodes. So the paths are 1 to 4, 1 to 5 and 1 to 6. Okay. So after having this tree which is what written as a this is what the array list which is used for storing the nodes of the different paths, and simply we call find paths where we supply the root and also the array what we created. Then we initialize with what actually 0. That means the path length initially is what 0. Okay, right. So when the first call happens, so here yeah, so when the first call happens, the root node is what actually the root node is 1. So it is not equal to null because there is a node is present. So due to that we have to add the node. So now we have to add the node in the path list. So path will in path of 0 because that is the first value of path length. Okay. So in path 0 we take node 1. That means we have to write the node data 1. Okay. After then we have to increment the path length. So it is going to 1. Right. Afterwards we have to check whether it's a leaf node. So the node 1, it is not a leaf node, it's having both left and right. So the else part for the node 1 will be executed. So here what happens, so root left in the sense so node 1 left is what actually left where we give the list. So the list which is what actually having the value 1 now, and the path length is what actually path length is 1. Okay, so now these values will be given. Okay, so node left is what actually 2. Okay, that is node 2, and node 1 right, that is it represent node 3. Okay, so the path which has the root node of both node 2 and node 3, that will be supplied, and here path length is equal to 1. So now this is the information will be given to the each call of the recursive function which is used to identify the paths. So in the sense it's going to one internal node, that is what 2 towards 2, and it's going to what another internal node, that is 3. Okay, so this is the thing will be happen. Okay, so these are the things will be given to the next calls of this recursive function. So now the second call which works for what the left side of the node 1, that is going to process node 2. Okay, so now root node is what actually 2. It is not equal to null, and also it is not so it is not equal to null, and it is a node. So where in the path length 1 we adding node data 2, and we increase the path length to 2, and 2 is not a leaf node. Okay, 2 is not a leaf node, so this may not be accounted. Now what happen is the left right of the node 2 has to be processed. In the left side node 2 left, what we have actually, we have node 4, and you see which is updated, the path which is updated with the previous root data also. So 1 comma 2, and path length which is incremented by 1, so that is what actually 2 now. The same information will be given to the right side of the node 2 also. Okay, that means it's going to supply the data to the right side of node 1, node 2, that is what 5, and path is what 1 comma 2, and whereas path length is what 2. Okay, so now the next call in the third iteration, it works for what the left side of the node 2. Okay, that is what node 4 has to be processed. So in this stage the root node is what 4, and this condition failed. Okay, now we come to what it is what a node. So due to that, in the path of 2 we add the node 4. Okay, and path length will be incremented by 1, so it moves to what 3. And now you see when we process node 4, it is what a leaf node. In the left and right side of the node 4, we can find null value. Okay, so now this function will be called when node 4 is processed. Okay, so due to that, what happen is the print function, okay, yeah, as I told you, this function will be executed. So it is what a function which is used to display the elements in the array. So what is the current elements we have in the array? So we have the elements from 0 to 2. Okay, 0 to 2. There we have the values like, that is, okay, we have the values like in we have the values 1 comma 2 comma 4. Okay, so now this will be displayed by using this. So now you see 0 to 3, what we have in the initial stage 0. Okay, so index 0 to 3, where in 0 we have 1 node 1, and in 1 we have node 2, and in 2 we have node 4. Okay, so now these three will be displayed as a result. Okay, right. So once the leaf node is reached, what happens is the print function is executed. Afterwards, that call is what? Removed from the memory. Okay, it is what vanished from the system. Right. So now what happens is the left side of node 2 is over. Now the right side of the node 2 has to be done. So that means we have to work for the node 5. Now the root node is what actually 5. Okay. So root node is now 5, and it is a node, so where we can store the data 4, node data 5, and the path list which is getting updated with 5, and the path length is also incremented by 1, not from the previous stage. Actually, you see the path length currently is what? 2. When you call, you can see that when you call the right side of the node 2, okay, so it is incremented to 3 from 2. Okay, afterwards when we process node 4, what happens is it is a leaf node. When we process the node 5, it is what a leaf node. So now this condition will be what? True. So due to that, the print function will be executed as which was executed before for 4. Okay, so the same index 0 to 3, we have a copy of the list. So you see in each so what happens is whenever you supply the data, it is what actually taking a copy of the path list and it given to its other levels, okay, child levels. Okay, so now we have the same nodes 1 and 2, but in the index of 2, what we have is we have node 5. So now 1 to 5 will get printed. Okay, as like that. Okay, afterwards, now you see the right side call which is over, but still, okay, so the right side call for node 2 is over, and also the left side of node 1 is over. Okay, so left side of node 1 is also over. Now still the right side is pending for the node 1, that is 1 right. Okay, that is node 3, where the path is consists 1, path is having the node 1, and path length is what actually 1. Okay, now it has to be processed with the node 3. So that time when the call comes for this function, so the root node is what 3, and it is what a node. So now we have to change the value. So path is what actually, path length is 1, so path of 1, where you can have the node 3. So now 1 comma 3, that is what updated, and path length which is moving to 2, and the node 3 is not a leaf node. Okay, node 3 is not a leaf node. So now this condition may not be happen for node 3 because it's an internal node. So what happens, it has to work forward the left and right of node 3. Okay, so 3 left, where it gives path of 1 comma 0, sorry, path 1 comma 3, where path length is 2. Okay, and node 3 right. Okay, that is we have the node 6 where we supply the path list which consists 1 comma 1 and 3, and path length is what, 2. Okay, so now when the call which works for the left side of node 3, where the left side of node 3 is what, actually there is no nodes, we can see. So the left side of node 3 definitely it is what having the null, that is null. So due to that, when the call is happening, it returns what, nothing. Okay, because now root node is what, null. So due to that, this condition is satisfied. So it is what, returning empty statement. So it just stops the execution of this function. It may not return anything to the this function call when it is happening for the left of node 3. Okay, so now there is no resource will be happen when this statement is executed, right? Afterwards, now the right side of node 3 has to be executed where we have the node 6. Now the root node is what, actually 6, and it is what a node, and also the path length is what, actually 2. Okay, so in the index of 2 where we can have the node 6, so that means 6 which is added into the list. Afterwards, path length which is moved to 3. Okay, it is incremented by 1, so it's moved to 3. Then when we work for what, when node 6, okay, 6 is a leaf node. Okay, so this will be executed, that means the print path will be called. Okay, so as like what we have seen for node 4 and 5, so in the index of index 0 to 3 we have 1 in the index 1, and we have node 2 in the index, so we have node 3 in index 1, and in index 2 we have node 6. Okay, so now these will be displayed by using the loop statement. Okay, that's the output of this function. Okay, afterwards what happens is the right side is over, no, so there is no more nodes to execute, so the function which is what, actually stopped. Okay, so we can see the results as for the list of different paths in the given binary tree to reach the leaf node from the root nodes. Now you can see that 1 to 4 that will be given first, then 1 to 5 the right side of the node 2 which is what displayed, then 1 through 6 the right side of the node 1 which is what displayed. Okay, I hope you guys understand about the logic present in implementing root to leaf. So please kindly take a notebook and also work out with this example, and understand about the logic of it. It is highly required one to understand the logic how the DFS function which works, and also the list which is what actually created, and the copies of the list which is processed in the different levels of the tree. Okay, thanks for watching this, and also please subscribe this channel to get the new videos. Thank you.